All right, advent of code, day 8. You barely reach the safety of the cave while the whale smashes. Submarine slowly makes its way to the cave system. 4-digit 7-segment displays. Each digit of the 7-digit display is rendered by turning on or off any of the 7 segments A through F. Oh my goodness. So to render a 1, only segment C and F would be turned on. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers by producing output on signal wires A through G. Those wires are connected to segments randomly. The wire segment combinations are mixed up separately for each 4-digit display. So you know that this only signal wires B and G are turned on, but that doesn't mean segments B and G. Only digit C and F are meant to be turned on. For each display, all 10 unique signal patterns you see, and then write down a single 4-digit output value. Each entry consists of 10 unique signal delimiter and then finally the 4-digit output value. Okay. Stirs.each do stir. Before, after equals stir.split. Before inputs equals before dot split dot map strip. After inputs determine mapping inputs focus on the easy digits. Oh. Okay. In the output values, C equals 0. After inputs dot select s dot length 2 3 7 4 include count puts C 800. Nope. $40. 2 3 7 4. I'm working on advent of code exclamation advent. 2 1 4 7 8. 26 instances of digits that use a unique number of segments. Puts after input step. Damn it. 375. That's a bummer. Oh, God. Okay. Add up all of the output values. Okay. Zero. Inputs. Okay. 1 equals inputs dot find I dot length equals 2. 4 equals 4. 7 and 8. 8. 8 is 1, 2, 3, 4, 5, 6, 7. Okay. Okay. So top equals dot cars top equals 7 minus 1. All right, that gives us top. We know 8. TL mid equals 4 minus 1. Bottom equals, oh, but I don't know which one is 9. Top left mid. Okay. 0 is 6. 2 is 5. 3 is 5. 5 is 5. 6 is 6. And 9 is 6. Okay. So I can do bottom left 6, 9. Oh no, that's 0, 2. 0. 2, 3, 5. Okay. So I found the top one, and now 0, 2, 3, 5. All right, I'm just trying to find patterns that'll let me like subtract things. Diags equals, oh, wait. Uh, 0, 6, 9. Two, 3, 5. Mid bottom equals 2, 2, 3, 5. IRB 1, 2, 3, 3, 4, 5. Yes, Ruby's the best. 2, 3, 5, 1, 2, 3, 5, 2. That gives me the minus top. Mid equals TL mid intersection mid bottom. TL equals TL mid minus mid. Bottom equals mid bottom minus mid. So I have top, mid, bottom, top, left. Top, mid, bottom, top, left. So I still need top right, bottom left, and bottom right. Bottom left between 2, 3, and 5. Top, mid, bottom. Aha. Okay. No, damn it. Okay, so 6 equals 0, 6, 9 dot find I dot cars minus 7 dot length equals 4. So that gives me 6. Bottoms equals 6 minus top, mid, bottom, top left. Bottom right equals bottoms 1. Bottom left equals bottoms minus 1. Top right equals 8 minus top, mid, bottom, top left. Puts top, mid, bottom. Mapping. Puts mapping. Inspect. Part 2. Puts what do I call this? Determine mappings. Mappings of before inputs. Uh, 31. Top is D, mid is F, bottom is C, top left E, top right A, G, B. Perfect, it worked. And now def value mapping inputs. Sum equals 0, digit equals 1, inputs dot reverse each do input sum plus equals cars equals values equals 0 TL top TL to your right, one, 2, 3, 4, 5, 6, 7, 8, 9. All right, 1 is top right, bottom right. 2 is top right, bottom mid, bottom left, bottom. 3 is top right, bottom right. This is also 5, except it's top left, bottom right. 4 is top left, top right, mid, bottom right. 6 is top right instead of top right, it's mid. 7 is top left, bottom right, no, top right. 8 is mid. 9, everything except bottom left. Values dot trans values dot each do value keys keys dot map k mapping k join dot sort dot join value to h map lookup sum lookup input dot cars dot sort dot join sum digit times equals 10. Puts decode mapping after inputs puts five. Perfect. And you want to know the sum? Adding all of the output values in this larger example, puts There we go. 271. Okay. Oh my god, I totally forgot to start the timer. Yo, thank you for the sub. Going well. Just finished Advent of Code. Day 8. And it went okay. Time to go over this problem because this one was difficult. So, day 8, 7-segment search. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Sensors indicate another exit to this cave at a much greater depth, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays in your submarine are malfunctioning. They must have been damaged during the escape. You'll be in a lot of trouble without them, so you better figure out what's wrong. Each digit of a 7-segment display is rendered by turning on or off any of 7 segments named A through F. So 0, you return on all the ones on the edges, 1, the 2 on the right, 8, you turn on all of them. The problem is that the signals which control the segments have been mixed up on each display. The wires are connected randomly, and they're mixed up separately for each 4-digit display. So you know that some signal turns on 2 things, but you don't know which 2 signals those are. For each display, I watch the changing signals for a while, and I make a note of the 10 unique patterns that I see, and then I write down a single 4-digit output value. Using the signal patterns, you should be able to work out which pattern corresponds to which digits. So the 10 unique values that we see are like 10 numbers, and then we see 4 more values after. Yeah. Within an entry, the same mapping is used. 7 is the only digit that uses 3 segments, and 4 is the only one that uses 4 segments. We can figure out some of the mapping, so he gives us a hint to start off with. And then we also know that 8 and 4 also use a unique number of segments. So for part 1, we just want to know which, in the output values, how many values are there that only use 1, 4, or 1, 2. How many values have a length of 2, 3, 2, which is 1, 3, which is 4, 7, which is 8, and 4, which is 4. 1, 7, 8, 4. So we just count how many values have that length, sum it up, and that's part 1, which is pretty simple. But then for part 2, we need to deduce which wires are which things. And that's a little tricky. And then once we know which wires correspond to which things, then we need to look at our 4 output values, figure out which numbers those correspond to, and then read that off as a number, and then take the sum of all of our output values. So, puts. So determine mapping of inputs. So thankfully, Ruby is pretty helpful here, because in Ruby, if you have two arrays, you can subtract them and you can intersect them, and you can also union them. And so that makes things a lot easier. Yeah, so basically this is the way I did it. Who knows if this is the fastest? This is definitely, I don't know if this is the fastest way to do it or not, but this is the way that I did it. So here we have our segments. These are we find the thing that has a 2. That's our 1 chars. The 4 has 4. The 7 has 3 characters. The 8 has all 7. And then we get the characters of those strings. So that gives us an array of the segments on in 1. The array of the segments on in 4 and 7 and 8. Similarly, we can get the 2, 3, and 5s by getting 2, 3, and 5 all have 5 segments, and 0 and 6 and 9 all have 6. So we can take the 7, which looks like this, top right, bottom right, subtract the 1, which is the 2 things on the right, and that'll give us the top. So that's pretty simple. We can subtract the 1 from the 4 to give us the 2 things that are the top left and the middle. To get the middle and the bottom, I guess the easier way to get the middle and the bottom would be 8 minus 4 minus top. So that's an easier way to get the middle and the bottom. We take the 8, subtract the 4, and then that leaves us the top, bottom, left, and bottom. So we could do that. Or no, oops. Okay, so this is what I did. So I took the 2, oops. So the 2, the 3, and the 5 all have the top, the middle, and the bottom. So I take the intersection of 2, 3, and 5. Do I ever use the 0, 6, 9? Yeah. So I take the intersection of those, and then I subtract the top to get the middle and the bottom. Then, because I have the middle and the bottom, and I also have the top, left, and the mid, I can intersect those two to get the middle. Then I can subtract the mid from the top left and the mid to get the top left. Bottom is mid and bottom minus the mid. So now I still need top right, bottom left, and bottom right. I can find the 6. So I have the 0, the 6, and the 9. And the 6 is the only one that only has 2 overlaps with the 7. So I take the 0, 6, 9, and I find the one that when I subtract the 7, it still has 4 values. And then from the 6, I can do, from the 6, I subtract the top, the mid, and the bottom, and the top left, and that gives me the 2 bottoms. Then the bottom right is the thing that intersects with the 1. The bottom right is the bottoms that intersects with the 1, and the bottom left is the bottoms that doesn't include the 1. And then to get the top right, I can just subtract everything from 8, and then get that. So then I have the mapping from top, mid, bottom, top left, top right, bottom left, bottom right. So then from there, I need to, I get the mapping. Processing the input is pretty simple. I get the mapping for the inputs, and then I decode the mapping. And so what I do is, this is a hard-coded map from each number to the segments that it corresponds to. So then I take this map, I map over it for all the keys. I look up those keys, I loop over the keys, look them up in my mapping. So that gives me an array of characters. Then I sort them, so it's deterministic, and then I join them together. And that gives the string that represents that number. And then I return an array, a 2-element array of the key and the value, and then I call toH on that. So that gives me the mapping from which string corresponds to which number. And then I loop over my inputs in reverse order, multiplying by 10 each time. For each input, I take the characters, I sort them, join them back together, look that up in my array, multiply it by like my, whatever, like hundreds place power of 10. And then I add that to my sum, and that's how you decode them. And then the sum, you just, part 2 is just the sum of the decodings. So we get that. And for the example, we get 26 and 61229. Cool. That was a fun one. Yeah, so that is December 8th, Advent of Code, day 8.